understand that is shrinkage in concrete. Now, from the name itself is clear that shrink mean there is some decrease in volume. So due to volume changes in concrete, now there may be some of the regions, maybe due to temperature rise, volume may change or volume may increase, decrease, etc. So shrinkage is the another factor which is very important. Shrinkage of concrete. Now let us understand. Strain can also rise in concrete due to change in humidity and temperature of the surrounding with time. You are aware when a structural element is constructed in any type of building, RCC type of structure. So then what you can easily understand that with the change in duration as well as time, even with the change of the, or you can say during the day and night, you will be finding some temperature variation in day and night. So these type of humidity may change, temperature may change. So it is wrongly written here. Strain. It is basically strain. So strain can also arise in concrete due to change in humidity and temperature of the surrounding with time. Now, concrete shrink in its hardened state due to evaporation of water due to any region, maybe because of change in ambient temperature. So what will happen? This will reduce the volume of concrete. When water is evaporated, then volume of concrete will reduce, and due to that some drying shrinkage will take place. And if restrained, if that means if that particular structural element is restrained to shrink, then what will happen? There will be cracks or deflection, and that type of cracks are known as shrinkage cracks. Earlier we have gone through creep, now it is shrinkage. So cracking due to shrinkage of concrete, they are known as shrinkage cracking. Drying shrinkage, as we have discussed, will lead to micro cracks, and when the concrete structure is prone to micro cracks or some cracks are emerging in the concrete member due to evaporation of water, it will definitely influence the strength of the concrete. That means it will weaken the concrete structure. Shrinkage also induces time-dependent strain. Let us go through the graph. Now you can see here along y-axis it is shrinkage strain, and along x-axis there is time duration. Now this time is calculated after 7 days of moist curing. So from this graph it is clearly visible as the time is increasing here, shrinkage strain is increasing. So here what we have written that shrinkage also induces time dependent. That means the shrinkage strain due to shrinkage also depends on the time, that means which we can see here, and after a particular duration you may find that the curve is getting almost flattened. Now here you can take the help of IS code 456 and clause number 6.2.4. So okay, so clause number 6.2.4 of IS 456 can be referred again for factors which creep of concrete depends, as already we have discussed. Now effect of shrinkage of concrete on RC, what will be the influence? So first of all, as we have discussed, if there is any type of shrinkage, then concrete will try to just get shrink, and if it is restricted to shrink, then stresses will develop, and it will increase the internal stresses, deflection as well as curvature. So it will be directly influencing the geometry of the structural element. Again, loss of pre-stress in pre-stress concrete structure will also be due to the shrinkage of the concrete. Now here, another point which we have to keep in mind, shrinkage can be minimized by reducing water cement ratio, by increasing the total aggregate content, and controlling the evaporation of water in the concrete. So here, later on you will be able to understand that how evaporation of water can be controlled. That's why we are using the curing of the concrete. So curing method is, if curing is done effectively, then you can just control or reduce the shrinkage effect on the concrete.